Hi, I'm Noah, and today we're going to continue with Arduino basics. And this time, we're actually going to be using Arduinos. So, Arduinos are these little blue circuit boards that allow me to make all sorts of fun stuff. Today I'm going to be using an Arduino Uno, which I would recommend as a good Arduino for starting out, as it has a nice balance of all the features you would want without all the extra complexity. Arduinos are open source, so many of them are made by third parties. This one, for example, is made by Freenove. And although it may lack some quality of a genuine Arduino, it functions identically at half the price. And it's got some cookie stuck in it from the robotic arm video. On the left here, the Arduino has two ports, a barrel socket for power, and a USB input, a type B in this case. In the top left corner, there is a small red button. This is a reset button, and the Arduino will restart its program when it is pressed. In the middle here, we have our processor. This is removable, however there isn't much of a reason to swap it out unless it's broken. It also has some onboard LEDs to indicate power, pin 13, and data transfer. The pin 13 LED, also known as the onboard LED, simply lights up when digital pin 13 is active. This can be used for testing or bug fixing. The data LEDs, labeled TX and RX, show whether any data is being received or sent via the USB data line or pins 1 and 0, which also act as data lines. Finally, and most importantly, around the edges of our Arduino are 4 banks of I/O pins. The top 2 here are the digital I/O pins. I/O stands for input-output, by the way. These pins are used to interact with your circuit using the Arduino. There are 14 in total, labeled 0 through 13. However, pins 0 and 1 are used for serial communications, so unless you're desperate for extra pins and want to sacrifice your serial comms, you should avoid using them. No, scratch that, don't use them. It just isn't worth it, as it can make bug fixing very, very hard without serial communications. If you want more data pins, just go and get yourself an Arduino Mega or Duo. So, digital pins can either be on or off, high or low, 1 or 0, a New Hope or the Phantom Menace. I think you get the point. There's no in between. Revenge of the Sith was okay, I guess. But digital essentially means either on or off, no in between. Although this does have one major exception in the name of PWM, but we'll get into that in a later episode. On the bottom edge of the Arduino here, there are 2 more banks of pins. On the bottom left, we have power connectors, pins for outputting 5 volts or 3.3 volts, ground connections, and a voltage input pin, labeled VIN. This allows your circuit to power your Arduino. And finally, on the bottom right here, we have analog I/O pins. Analog is essentially the opposite of digital. Analog pins can give a range of values. They can be used to control anything from the brightness of an LED, or they can measure a specific amount of voltage coming in from a sensor. They really are the jack of all trades. And to top it off, you can even use analog pins as digital pins, if you need to. However, there are only 6 analog pins on the Arduino Uno, so use them wisely. Now that we've talked about the basics of Arduino anatomy, let's hook it up to a circuit. Here we have essentially the simplest circuit that you can build with an Arduino. I am running the Blink example from the Arduino IDE, and you can see it is flashing the onboard LED here, so pin 13, at an interval of about 1 flash per second. I've hooked this LED up to pin 13 using a jumper wire and a 220 ohm resistor. If you are curious as exactly why I have this set up, go watch the previous video. And essentially here, when that LED is powered, pin 13 is powered, which will then power this LED. Now let's get on to something a little bit more complicated. So this is a slightly more complex example. I've got the same LED here, rigged up to pin 13 still. However, I've reprogrammed it and it doesn't flash automatically. I've also got this button here, which is hooked up to pin 2. Digital pin 2 there, you want to start with pin 2 as you can't use 1 or 0. And the button here is straddling this spine of the breadboard, as the contacts do not connect on either side. On the other side of the button, I've got this jumper wire here which goes to ground. So essentially this button is acting as a sensor, and when I press this button, what it's going to do is it's going to short circuit pin 2 to ground, therefore telling the Arduino, hey, pin 2 is low, you need to do something. And I've coded it in such a way that when pin 2 goes to low, then it will flash digital pin 13. And you can see when I press this button here and I hold it, pin 2 is now low and the LED flashes. As you can see, these circuits are in no way connected. This is all being done by the Arduino. When I release, it stops. So all of this is very simple and probably something you could implement without an Arduino. It sort of shows the kind of stuff that you can do with an Arduino. This example is much more complicated, and it uses a combination of digital and analog pins in both input and output modes. So essentially what we've got here is a flashing LED. This is hooked up to pin 2, although it doesn't really matter which digital pin it is attached to. You can see it's got a resistor to ground, and its anode is connected by this green wire to pin 2. As a control for the LED, we have this potentiometer. You can see when I twist this knob, the interval of flashing changes. So when I have it all the way up here, it turns off. But if I slowly increase it, you can see it goes from solid to blinking more and more and more and more and more. And then it blinks slower and slower and slower and slower until I eventually crank it all the way this way. And there it's cranking at about a 1 second interval. It is blinking. It's got a power line coming in on this side, a ground line coming on this side, and essentially the potentiometer, just depending on where you turn it, it just balances between power and ground and sends that signal into A0. The Arduino is then reading the signal from A0, and it is using that signal to determine what the flash interval should be, and it is programmed in such a way that it is going to constantly blink and change the interval as I twist this knob. So this is the sort of thing that would be very hard to do without an Arduino, and this is something you could build yourself in 2 minutes, whereas without an Arduino this would take you way more time and effort, and probably a much more complicated circuit. If you want to try this one out for yourself, simply pause the video right here, take a screenshot. You can build the circuit based on what I have here, and I will link the code in the description so that you can download it and try it out for yourself. Next time we'll probably be talking about how to program your Arduino, but for now, thanks so much for watching and have a good day.